In this tutorial, I'm going to use an aid to find a target that is almost invisible and extract a light curve from it. I'm going to open an AVI file to demonstrate. I'm going to use this file, which is a drift-through video that David Dunham acquired, and I acquired through Tony George. Our first step, as always, is to put this AVI into a folder. I accept the default locations. And let's take a look at what the star field shows us. I happen to know that the target is somewhere in here, but I can't really see it. So this is a place where people would often use a program like Registax to enhance their image. And that's such a good idea that it's been built into PyMovie. We can generate a mini Registax, if you will, which we call generating a Finder image. If I just go ahead and click Finder image, it's going to warn me that I have to remove any timestamp overlay because that can keep the procedure that we use for aligning the frames with each other from working. And I didn't specify the number of frames to use. So I know that redacting about 70 lines, a positive number will redact lines starting from the bottom moving up. And about 100 frames is a pretty good number of frames to use for Finder image. So now we're working on generating a Finder image. First, I have to confirm that the timestamp was completely removed. Once I agree that it was, it will proceed to generate a Finder image. And it warns me that when I snap to a Finder image, I should make it a no-snap aperture so that when I flip back to the actual video, the aperture doesn't move. That's what this little warning message is all about. So let's do a little zoom in on this, contrast-wise. And I can now see, although barely, our target. If I put a snap to block, put an aperture on this, a static aperture, I see in fact that there's this little 3-star asterism is what I'm looking for. And here is the target that previously I couldn't see. So what I'll do is I'll enable jogging, do a slightly better positioning to finish that. And let's go back to the real AVI. We have to reset our contrast control. And you can't really see that there is a target under there, but there is. First of all, let's note that we're never going to get an image out of this one that's reliable enough to track. We can go ahead and set a threshold of, let's say, 12, but most of the time it's going to be following a default mask. So we're basically going to be doing regular circular mask photometry on this target. Well, since this is not only a very, very dim target, but also a drift-through video, we're going to need to use a tracking star. So I'm going to pick this. I'll do a snap to blob and we'll call that our tracker. And we'll set its threshold at about 2 sigma. That looks good. We'll designate it as our tracker. And finally, because we're trying to find an image that's almost not there, we should give ourselves a no star so that we can compare what we're getting out of the measurement aperture from an aperture that's placed where we're pretty sure there's no star. I'm going to use one right up here. I'm going to call this my no star. And I'm going to set its default mask to 3, its threshold to 12, and we're now ready to begin our analysis. I'm going to make this the thumbnail source, and I'm going to start the analysis. So we are now analyzing. I'm going to pause this video while this analysis completes, as this does take some time. Okay, we're nearing the end of the analysis. You probably have seen a big jump on the apertures. It's because this was a drift-through video. So let's see what we've gotten from this analysis. I'll open the plot. And I can see from our legend that the no star is in blue. That's down here. And our star, our target, which I forgot to label, but it's aperture 00 because tracker is in green. We see that that is mostly above the blue, except here. We probably did, in fact, record an occultation. So let me just slide this up out of the way. And here was our no star aperture. It looks like it had about an average value of maybe 40. Let's look at our tracker. Nothing untoward was happening with it. And finally, we look at our target. And we can see that the average, the baseline, was 100 or a little more, which says there really was light there, in spite of the fact that we couldn't see it. And we, in fact, did record an occultation. And that is the end of this video.